Good morning, good evening, good afternoon. Hi everyone. It's my great pleasure and our pleasure to have the FML-based machine learning competition for human and smart machine co-learning on real-world applications. So Claire, can I share my video now? Share my screen.
Yes, go ahead.
Okay. But now cannot work here. Okay, first of all, I would like to say thank you very much for the organizers. The organizers contains I am Zhang Xinli from National University of Tainan, Taiwan, and Yusuke Nojima from Japan, Giovanni Acampora from Italy, and Marek Reforman from Canada, and now Yuki Kubota from Japan, and Saka from Japan, and Professor Yi Chengwu from Taiwan, and Soto from Spain. So this is our organizing committee. Then today, for the FML-based machine learning competition, we will have the program as follows. First, we will have opening and introduction. The session chair will be Zhang Xin, Mei Hui, and Professor President Yang. Then we will go to the section 1 for the university group. For the category B and C, we invite Yusuke, Nojima, and Amir to be the referee. There are total 16 to join this competition. First round, 5 teams, and final 3 teams. So today we will 3-team video to report. And we also invite 2 companies for IEEE 1855 for industrial applications, including Nuwa Robotics and NUTN Taiwan, G System Technology and NUTN Taiwan. Then finally, we will have a Q&A. Then session 2 for the elementary and high school group at Tainan City, Taiwan. Because of the COVID-19, so the situation in Taiwan, we cannot at the same hotel, at the meeting room. So the student from the elementary school all connect to internet. So this is for category B and C. We invite Soto and Mary Gina to be the referee. So the total is 18 from Tainan City, first round, 4 teams, and final 3 teams. So we will invite 3 teams from Render Elementary School to report. And we also invite 1 company for IEEE 1855 for industrial applications, media wave intelligent communication to show the video and to report the result. Then for the session 3, we invite the elementary school and high school group from Kaohsiung City, Taiwan for the category A and B. We invite Marek Reforman and Giovanni Acampora for the referee. So the total are 19, and first round are 15. Final, we invite 3 teams to report at this conference. So we also have 2 company introduction in this section. Finally, section 4, we will have conclusion and discussion. So we also invite the Professor Hong Dun Yang, President Yang for the AI FML International Academic Competition and Discussion. So this is today's program. So the result, if you are interested, you can see here. And on the website, we also have the promotion for the logos. So you can see for the logo, we design 4 logos. And we also have poster and the video. So all the video, we also put on the Google site in our competition website for the session 1, session 2, and session 4. Then we also have some promotion video for CI on real-world applications in Taiwan. And finally, we also have some connection from Italy and Taiwan, Spain and Taiwan, Japan and Taiwan, and so on. So for the robot. So now we would like to invite the AI FML International Academy, the president for AI FML International Academy, President Yang, to say something. And for the opening, President Yang, please. Thank you.
Okay, everybody. Hi, my dear friends. My name is Hong Dun Yang. What's name as the honorary president of the AI/ML International Academy. I'm happy and honored to be invited to be here, have a chance online here to say hello to everyone. Hopefully you are healthy and working very well in this COVID-19 pandemic period. As I know, we supposed to be in the meeting of the Luxembourg at this moment. Well, we just online here. It's very difficult to imagine when and what will be in the near future. Hopefully, we are able to meet face to face in the future, maybe in Italy next year, right? Okay, I'm not sure how many members, international member or Taiwan members are online, but anyway, they will. Changxing told me they have two members individually from city of Kaohsiung and city of Thailand government. They will join us, and also 4 members from industry, from a company, right? Will join the competition to look at the event. To make this the event possible, the competition, of course, you are joining and effort is very important to make this event possible. I'm also I would like to thank or give the very special appreciation to Changxin Li for his and his team and for his group work very hard to make this competition, invited international referees and so on, and coordinate many teams in Taiwan in the past few months. Also, I in fact, just but you know that I'm not an expert in the artificial intelligence, the field. But anyway, I happy to look at the good development, good progress for you guys. Make a lot of effort for the AI education in our young generation to pick up the the current stream of the science and technology. Hopefully, our new generation will be have a good development and good achievement in no matter in Taiwan, Japan, Spain, UK, Italy, and so on. Finally, I would wish everybody healthy and happy. Thank you very much.
Okay, thank you, President Yang. So President Yang, I see the Amir is online and Yusuke Nojima also online.
Okay, I just say hello with them.
Say hello. So Amir, will you please say something on maybe 1 or 30 minutes? Okay. Amir,
yes,
please.
Yes,
Thank you.
Okay. Hello, everybody. Thanks a lot, Changxing, for your efforts. I think you are a very active person in engaging the community of young people to this activity. So I'm very happy to work with you. Now, so I'm very happy to be in this meeting, seeing very young faces here that are working on FML and AI and all sorts of intelligence, smart stuff. My name is Amir Pur Abdullah. I work in Nottingham University, Nottingham Trent University. So I teach some artificial intelligence modules, and I also had some experiences on fuzzy systems. And so in general, I will be happy to look at your works, and I think by reaching here, you all are winners, but perhaps after today, we have some very top achievers that you will see. And from now, I prefer to listen to your works and to watch your presentations. And after that, if I have any question, I will let you know. Thank you.
Okay, thank you very much for Amir. Later, Amir will have a short course for the high school engagement to
Yes.
introduce the neural network.
Yes, that's right. That's right.
Thank you. So next, we would like to invite Yusuke. So Yusuke will also have a short course later. So Yusuke, our organizing committee member and our VP. So Yusuke, please, thank you from Japan.
Thank you very much for your introduction. I'm Yusuke Nojima. Nice to meet you. Nice seeing you again. Yeah, I'm Yusuke Nojima from Osaka Prefecture University, Japan. My comment is very short. I'm very looking forward your presentation, and I hope enjoy everyone every presentation. So yeah, that's it.
Okay, thank you, Yusuke. So many Gina also online. So from friends. So many Gina, please. Thank you. Could you please say something?
Yes, hello. Just wanted to say hello and thanking you for organizing this event and saying hello to all the participants. And I'm sure it will be very great. And I'm very happy to see that the young generation is also so much interested in fuzzy logic and its achievements and contributing to the next achievements. So thank you very much to all of you.
Nice to see you.
Hi.
Okay, thank you, Gina. And next, we would like to invite our general chair, the Christian Wanger. Christian. Okay,
hello,
thank you very much for your great support for our activity for high school engagement and the competition. Thank you. So would you please say something? Thank you.
Lee, everyone, thank you very much. Thank you for all your work in organizing this. Thank you for everyone for supporting, and thank you for all the competitors. I think, like it was already said, great for making it to this stage. And yes, it's going to be exciting to see how the competition turns out. So good luck to everyone. Thank you.
Okay.
Okay, thank you, Christian. And next, we would like to invite Leo Guo from Nuwa Robotics, the CEO. So Nuwa Robotics help us for this competition very much. So Leo, please, thank you. Leo, please open your voice. No voice now.
Sorry.
All right.
Hi, everyone. Hi, I'm Leo. I'm the founder and CEO of Nuwa Robotics. It's my pleasure to work with Professor Lee to provide our KBL. I believe that's the world's most cost-competitive multi-axis robot in the world. So hopefully I can also have the pleasure to work with the professors in outside Taiwan over the world. Thanks. Thank you very much.
Thank you, Leo. And finally, we would like to invite the Director of Computer Center from Kaohsiung City Government and Tainan City Government. So Director Lin, would you please say hello and say something to the students? So Professor Lee from Kaohsiung City Government, please, thank you.
Hi, everyone. I am Director Lin of Computer Center for Kaohsiung City Educational Government. Thanks so much for this competition to support students of Kaohsiung City to learn CI for real-world application. Thank you.
Okay,
so you
thank
are in
you.
the car.
Okay, thank you. And I am not sure the Tainan City Government, the Director Gao is online or not. So if online, please, would you please say something to the students from the Tainan City? So if not, I think finally before the competition, we would like have a group photo. So would you please open your camera now? Then we will take a group photo together. Then we will start our competition. So Christian and Mei Gina and Shi Qi and Bao Zheng and Sheng Cheng and Pei Yu and Jun Kai and Hong Yi. And I think the Tainan city government representative also online. So Jun Kai, could you please open your camera? And Bao Zheng and Hong Yi and Shi Qi. So please, thank you. So then we will take group photo together. Then we will start our competition. So Alice, please say 1, 2, 3. Then take photo.
2, 3, smile. One more. 1, 2, 3, smile.
Okay, thank you. So next, so thank you all. So thank you, Christian, and thank you all. So we will start our competition. So Claire, would you please play the first video? Thank you. Hello, everyone. It's my great pleasure to invite the team from National University of Tainan, Taiwan, to report the AI FML with AIoT application on BCI-based music listening. So, Mei Hui, please. Thank you.
Hi, hello. My name is Mei Hui Wang.
Hello, my name is Wu Tai Guan.
Hello, my name is Shen Hui Huang.
Hello, my name is Ri Pin Chang.
Now we will introduce the IEEE 1855 AI FML with AIoT tools for BCI-based music applications. Wen Kai, please. Thank you.
Hello, my team name is OASE BCI. Our members come from NUTN Taiwan and Taiwan AI Academy. This is our outline, including BCI and AIoT tools, experimental architecture, experimental results, and conclusion. Finally, we will demonstrate BCI-based music application to IEEE 1855 AI FML with AIoT tools.
First, we are going to show BCI and AIoT tools. We propose the BCI-based key loop agent. This agent combines the AI FML robot with the concept of Heart Sutra to make it with the computational perception and the cognition intelligence. Computational intelligence (CI) contains fuzzy logic, neural network, and evolutionary computation. The core of CI is AI FML. Next, this slide shows some of AIoT tools. These tools follow IEEE 1855 standard for fuzzy markup language FML to communicate with our development of AI FML using MQTT or HTTP protocol. These tools contains AIoT FML learning tools version 3. We collaborated with Circus Pi Taiwan and AI FML robots, including KBL, Rua Robotics Taiwan, and Denbo Junior, ASUS Taiwan. Next, I will show two-phase BCI agent heat loop agent structure, including online EEG data collection and offline human emotions analysis. First is online EEG data collections. Humans wearing a BCI device are listening to music. The BCI FML agent at edge computing sends collected EEG data to the server and transfer the real-time info results to AIoT FML learning tools and AI FML robots. The tools and robots receive messages from the server and show humans different emotions on their face. Second is offline human emotions analysis. Users create a KBRB through AI FML heat loop agent based on the collected data and train the model using PSO machine learning method. The AI-OT FML agents reflect humans' emotion. AI-OT FML learning tool using HTTP and AI FML robots and MOOC using MQTT.
And this is our experimental architecture. This is our fuzzy variables. We have 5 input fuzzy variables, including attention, left brain activation level, right brain activation level, fatigue, and stress. And our output is emotion. This is our fuzzy set and semantics. Every input fuzzy variable has 3 fuzzy sets, low, medium, high. And the output fuzzy variable has 4 fuzzy sets, depression, anxious, contentment, exuberance. This is before learning knowledge base. This is machine learning structure with 189 rules.
Next is experimental result. This slide shows our data collection. Total number of our listening songs is 12. It contains 4 language songs, including English, Chinese, Taiwanese, Japanese, and there are 3 songs in each language. This is the amount of data we have collected. Total number of data is 3,335. We split the collect data into trained data and testing data using the ratio 8:2. And this is after learning knowledge base. This table shows the experimental result after 1,000 generation training. We can see the MAC of the trained data is 0.017 and the testing data is 0.02. Next, we select the subject's most liked song and the most disliked song to compare the physiological indicators. We can see that when listening to the favorite song, the attention and the right brain activation level are higher. The fatigue and stress are lower.
Next, I will present our conclusions. We analyzed the relationship between emotions and brain physiological responses during music appreciation in different languages. The experimental results show that the subjects can be more focused and relaxed when listening to their favorite songs. It is feasible to integrate different AIoT devices with our developed AI FML platform and real-time show the emotions on the AIoT device face. In the future, we hope to promote them to children from different countries in the world to make them learn AI with fun. Finally, this is our demonstration of FUZZ-IEEE-based music application. Thank you.
Okay, thank you, the team from National University of Tainan, Taiwan. Thank you.
Hello, everyone. My name is Yiling Cai. I'm currently working as AI engineer at Taiwan AI Academy. In these competitions, I'm responsible for AI FML broccoli development. So now let me introduce the system functions. This is our AI FML broccoli system. We built with web application. The broccoli editor is an intuitive visual way to build code. It provides the graphical blocks to represent the code concepts like variables, logical expressions, loop, and more. In addition, we add some custom blocks in our broccoli, including the MQTT and the fuzz inference blocks. MQTT is a messaging protocol for the Internet of Things. These functions will connect to the network, which can subscribe or publish to a topic. The next is fuzz inference blocks. We successfully combine the blocks with IEEE 1855 fuzzy markup language. People can build up their own fuzz inference systems by FML tool. Then upload FML files to our AI FML broccoli. The AI FML broccoli can communicate with IoT device or robots and publish their inference results based on MQTT protocol to achieve the goal of human and smart machine co-learning. And the next part, we will demonstrations robotic real-world applications with AI FML broccoli.
No. Okay, thank you. So Amir, would you please ask some question? Then use case. Thank you, please. Hey, no voice. So Amir.
Sorry, I was muted. Okay, so it was a very interesting work. I enjoyed that. Perhaps one question came to my mind is that how did you find FML useful in solving this problem? I mean, with or without FML, can you compare that what advantages FML can give you to solving this problem?
Okay. So Wenkai or Alice, can you please explain the answer?
We first we collected the data and to construct the FML data to construct FML. And the advantage if we have the FML, it is very useful for people that he did not very understand the physiological. If he just use his domain how to construct the KB and RB using a tool, for example, AI FML system development by NUTN, then it is very easy to promote to young students, for example, high school students or elementary schools. I think this is an advantage. Thank you.
Okay, thank you.
Thank you.
So then Yusuke, please, thank you.
Hi, thank you very much for your great presentation. My question is that I think there are 5 inputs time series data. So how do you, please explain how do you handle those time series data as an input to FUZZ systems?
Okay, so Wenkai, could you please answer this question? How do you handle the data for the 5 variable? So Yusuke, right.
Do you mean how do you handle the data to construct the knowledge base and the role base, right?
No, my question is input data would be time series data.
Time series, okay.
Time series.
Yeah, because you use a BCI.
Yes.
Yes. Wenkai, can you explain the data? How do we handle the data? How to collect the data?
How to collect the data, Wenkai, please.
Collecting data.
No, handling the time series data. It's a time series data is like this. But
yes.
I think the input is only the single value.
Yes.
Per variable, right? So
yes.
how do you change the time series data into scalar value?
When we wear our BCI device and we will receive the data one second, one record. But it's too much for when we listen to a song, for example, 4 minutes or 5 minutes. Usually a song is like this period. And so first, when we need to sample, for example, we use 1,000 records. We just sample 100 records as our training data. So in this way, we can reduce the number of training data.
By sampling.
Yeah, by sampling. And this is the first method. And currently, we submit our paper to the journal. And we transfer time serial data into frequency domain data. And it will also reduce the number of the data when we listen to a sound clarity, the number of data when we listen to the sound.
Okay, use case.
Oh.
So maybe we can discuss after
later.
Yes, because
yeah,
of the time constraints.
I was thinking you use the kind of average value in certain time
we
period.
also use average value.
Yes, you are right.
Yeah, but I don't think it is enough transformation. So yeah, let's discuss later.
Okay.
Yes, we program a Python code to transform.
Use the Python. Maybe Yilin, are you online? Yilin Cai.
Hello.
Hello, Yilin.
Hello.
Would you please explain for the question from use case?
Okay,
yeah, so maybe I
think
misunderstood. Misunderstood.
Okay.
Okay. Hello. Can you hear me?
Okay.
Yes.
Okay, please.
Okay. We have the brain device. It can collect the brain signals, and these brain signals we use the Fourier transform processing this time series data, and in these transforms we will get the 5 different index. The 5 index is about the attention rate, right brain and left brain, fatigue and stress. These 5 index, and we use this 5 index to be our fuzzy inference input. So in our system, we have these 5 inputs, and the chain and fuzzy machine learning to predict the human's emotions. And this is our topic's goal. Yeah.
Okay, thank you, Yilin. So use case, because our competition chair Anna is come to this session. So Anna, would you please say something and say hello to everyone? Anna, our competition chair. Anna, no voice, mute. You are mute. Is it possible for you to say something? No voice. So okay. So
if there is a time, can I ask another question?
Oh yes, please, Amir.
Okay. All right. So for creating the knowledge base and rule base, you mentioned a method of machine learning that we have used, but I didn't actually understood what was that method. Could you please repeat that?
The machine learning. Okay.
Yes. What machine learning method do you use for knowledge base and rule based development?
Okay. So Wen Kai, could you please explain how to use the machine learning?
We use the PSO algorithm to do our machine learning, and we have do about 1,000 times generations.
Okay. What is PSO?
What is PSO?
What is PSO?
Okay.
PSO is the evolution algorithm. Is about how to say the whole name?
Particle swarm optimization.
Particle swarm. Okay.
Yes.
Particle swarm optimization.
Okay.
Okay.
Thank you.
Okay, thank you, Amir, and thank you, Yusuke. So Anna, our competition chair, can you hear me? So okay, next. So thank you. So Claire, would you please play the next video? Thank you, because of the time constraint. The second team. Hello everyone, it's my great pleasure to invite the team from National University of Tainan, Taiwan to report the AI phone tool for music listening. Xiaoqi, please, thank you.
My name is Xiaoqi Liu.
My name is Ziqi Chou. My name is Baozhen Chen. Hello everyone, my name is Ziqi Chou. My name is Baozhen Chen. My name is Hongyi Huang. I'm come from NUTN Taiwan. My report topic is AI FML for music listening. My team name is OASEKWS. Please cite short FUZZ-IEEE variables. 5 input variables: attention, rotational, emotional, fatigue, and stress. Output variable: feeling. This slide shows our motivation to AI FML for music listening. It has AI FML for music listening, AIoT application, human behavior, analyze human feeling, AI FML for fun.
Input， 然后这是 output。
This is our method: collect data, analyze data, feeling analysis, build knowledge base, build real base, PSO machine learning, AIoT application. This slide shows the AI FML with AIoT application. Step 1, human and robot co-learning. Step 2, record and collect data. Step 3, build KB and RB. Step 4, use PSO to do machine learning. Step 5, after learning KB and RB. Step 6, machine learning until a best model.
根据 AI FML 推论喜好程度为不喜欢这首音乐。
那它边算出来的是多少？
数值是0，
那反值也是0。好。
Although BCI is not so good now, it will become smarter after practicing again and again like humans.
根据 AI FML 推论喜好程度会喜欢这首音乐。
喜欢的话是跟这边的结果是一样的，然后这边的数值算是0.811，这边也是0.811。
好。
Thank you very much for your listening.
Okay, thank you for the team from National University of Tainan, Taiwan. Thank you. Okay, thank you. So now our competition chair, Anna, is coming. So Anna, would you please say something and say hi to all the team members? Please, thank you.
Hi, hello. Welcome to this competition. I would like to thank all the participants for their excellent contribution and also the organizers to organize this competition. And I hope that you have a lot of fun and you are enjoying it despite being a virtual event. We would love to host you in Luxembourg. It's a beautiful city with very nice weather and climate this time of the year. So it's a great pity, but still we hope you can enjoy this time to the best of the extent. And enjoy the rest of the competition, and good luck to all the participants.
Okay, thank you. Thank you very much, Anna, for your great support to our competition. So thank you. Thank you again.
Thank you.
Okay, see you. So I think so Anna, we will take photo now by the screen with you together. So I think we will the question for the second team. So Emil, please, thank you. But Emil, because the second team, they are freshmen in my university. 3 girls, they just help to do the experiments, and they so please, thank you.
Okay, thank you. To be honest with you, I didn't exactly understand what was the job. It was perhaps too short, or perhaps not clear. If they can just repeat in a very summary way, in a very short way, what is the aim of the system, what is the input, what is the output? Sorry, I'm not very clear about that.
Okay. Okay, thank you. So maybe Bao Zheng, would you please say something for your join this activity? And
what is the input and what is the output of the system?
Bao Zheng, can you hear me?
Input and output 吗?
Yes,
please.
Please, thank you.
Input include attention, left brain activation level, right brain activation level, fatigue, and stress. Now output is feeling.
Okay.
Input is what level? I didn't hear that clearly.
What level?
Left brain.
What?
Activation.
Left brain activation level.
Activation level, all right.
Yes.
Activation level.
And the right brain activation level.
And the left brain activation level.
So what is the music listening then in between?
What song does you listen to? Or then you listen to perfect, right?
Perfect. The music, English music, right?
Okay, so people listen to the music, and then you measure some signals from them.
Yes.
Okay, and then the fuzzy system will have this input, and what is the output then?
Yes.
Output is their emotion. For example, sad or
they
or
like
happy,
they're happy, like this song, or don't like this song.
All right.
Or happy.
Okay. So the system predicts if the right emotion of the people are collected.
Yes.
Okay.
So later for the Nuwa robotic company, they will also show introduction to this one together, combine together. Okay. Thank you, Amir.
Okay, so that the robot can visualize the emotion, is it the idea?
Yes.
Okay,
yes.
all right.
Okay, thank you.
Okay.
So
interesting job. Thank you.
Okay, thank you, Amir. Thank you. Yusuke.
Yes. I was thinking about almost same things, and
yes.
The answer on my question was already
okay. So
my question was okay.
So it's okay. So
it's okay. Yeah.
Okay. So maybe next the video from the Nuwa robotics. So Claire, please. Thank you. The next video is from the Nuwa robotics. So the same. So please, thank you. Start.
女娲造人，我们创造机器人。女娲创造追求的，并非设计出一台传统的人形机器人，而是能够跟人有温度的互动，以朋友的身份进到人类社会，并协助解决困扰的好伙伴。女娲创造属于你独特的机器人。
We have great capability in robot product development. We've assembled an excellent team with expertise in different areas, from design to hardware and software technology. Our core value is to make the robot not only an electronic product, but one with a distinct personality and human-like body movements. Besides this, Nuwa is capable of hardware and software development and social integration for a total robot solution. Nuwa is able to develop its own robot products or process co-developed products with global-scale companies. The robot is an integration of cutting-edge technology, including face and object recognition, natural language process, and autonomous behavior simulation. To make the robot an independent individual, it can be equipped with different content or devices. Features include body temperature measurement, object recognition, and social interaction, which make it perfect for use in households, education, healthcare, and service environments. UR Robotics, helping you make your own robot.
Hello everyone, it's my great pleasure to introduce the UR Robotics in Taiwan, the CEO Leo, to introduce the AI FML 1855 AI FML robot for real-world applications. Leo, please, thank you.
Hi, thanks for Professor Lee's introduction. I'm Leo Guo, the founder and CEO of UR Robotics in Taiwan. First, to support IEEE 1855 AI FML, the AIoT tools need to follow IEEE 1855 standard for fuzzy markup language, and also communicate with AI FML using MQTT or HTTP protocol. So our product, KB Air, which comply with the two standards I just mentioned above. And this slide, I want to introduce BCI fuzzy variables. We have two kinds of variable. One is for input. So for the input fuzzy variable or semantics, we have attention, LBAL, RBAL, fatigue, and strength. For output variable and semantics, we have emotion, depression, anxiety, accompaniment, and exuberance. And this slide shows the learning knowledge base before training. And this slide shows the AI FML machine learning structure. And this slide shows you the learning knowledge base after training. So the conclusion is, after integrate different IEEE 1855 AI FML with AIoT tools, with our developed AI FML platform, and real-time shows the emotions on AIoT device space, which is the robot KBL. And in the future, we hope to promote this platform with robots to children globally to help them to learn AI with fun. Thanks for your listening.
Thank you very much, Leo, for UR Robotics in Taiwan. Thank you. Okay, thank you. I think this is the introduction to introduce the UR Robotics with the AIoT and our BCI application. So Leo, would you please say something? Leo, please. Thank you.
Okay, thanks, Professor Lee. As I mentioned at the first beginning, I do believe and very confident that this robot is currently the world's most cost-competitive one with 12 degree of freedom with 12 servo motor, because we do servo motor by our own. So that's the reason why we can make such a AI-enabled robot such cost-effective. Okay, and the current CPU we use Qualcomm 8-core CPU, so it's also possible to run several AI just locally at the robot side, and you don't need to always connect to the cloud side. So I hope I also can have the pleasure to work with the professor, the expertise over the world. Thank you, Professor Lee. Thanks.
Okay, thank you, Leo, and for your support for this competition. So Amir, so the presentation just introduced how the BCI device connected to the robot KBL. So because of the time constraint, so we will invite the 3 video, the next, okay? So clear. Next, please. Thank you. Next video. Hello, everyone. It's my great pleasure to invite the team from National University of Tainan, Taiwan, to introduce the AIoT with AI FML for student learning. So, Mei Hui, please. Thank you.
Hi, hello. My name is Mei Hui Wang.
Hello, my name is Dong Han Qiu. Hello, my name is Yun Hao Zhai.
Hello, my name is Ren Ping Shao.
Now we will introduce the IEEE 1855 with the AI FML and AIoT tools for student English speaking and learning. So, Zhonghan, please. Thank you.
Hello, everyone. My team name is FUZZ-IEEE. Our members are from NUTN Taiwan and the Taiwan Academy. This is our outline.
First, we are going to introduce our motivation and goal. Our motivation is to make AI FML robust to interact with students and learn each other. We design various AI FML applications to make it easier for students to learn AI, and we observe students' ability and learning performance to adjust the contents of the course effectively. Our goal is to promote and introduce AI FML robust and AIoT FML learning tools to different teaching fields. And we realize human-machine co-learning by AI FML intelligence speaking English. We analyze the students' performance based on the collected data. Next, I will show AIoT FML learning tools version 1 and version 2. These two learning tools follow IEEE 1855 standard for fuzzy markup language FML to communicate with our development AI FML using HTTP protocol. We cooperated with the Medium Web and these system companies in Taiwan. Next, I will show AIoT FML Mooncar and Microbit. They also follow IEEE 1855 standard, and we cooperated with Juno and the CircusPy companies in Taiwan.
Next, we will display our architecture. This figure shows our architecture including teaching and learning, and the feedback and the aligned. First, teachers are teaching and the students are learning. Second, students co-learning with AI FML robots to do data collection. Next, AI FML system implements AI FML fuzzy inference and PS4 machine learning. Finally, students provide feedback and to make a further analysis. Next is our methodology discussion. This slide incorporates our AI FML methodology to do intelligent English speaking learning. First is the human and the machine co-learning English to collect and record data. Next is to build KB and RB using AI FML platform. AI FML system implements based on machine learning data inference and the data analysis. Finally, we deploy the learning model to predict the future student English learning performance. I will display our experimental result. First, it's our AI FML knowledge base. We have 3 input body variables, including purchase time, purchase number, and average score. The unit of purchase time is second. The output body variable is learning performance. This figure shows the before learning knowledge base. This is the bi-layer machine learning architecture. The total number of body rules is 27. This slide shows our training data and testing data. Training data come from different teaching fields in Taiwan. And the total number of training data is 451. Testing data come from students of NUTN Taiwan. The total number of testing data is 19. This is after learning language base for 500 generations. Next is our experimental result. We use RMSE, MSE, and accuracy to show the performance. MSE of learning 500 generations is the lowest. This slide shows the bar chart of RMSE and MSE for learning different generations.
Next, I will present our conclusion. In the classroom, the students interact with AI FML robots or AI-OT FML learning tools. We use AI FML agents to conduct the AI FML intelligent speaking English human machine co-learning. We observe and analyze students' learning performance. The AI FML agents provides personalized contents based on different persons and plays a bridge between human teachers and AI FML robots or AI-OT FML learning tools. Human teachers or students construct the knowledge space and rule base using AI FML platform and use a human-like language to achieve the goal of human and machine co-learning. Human and machine co-learning models is popular with elementary school and high school students and can improve the learning performance of students. Finally, it is our demonstration of AI-OT application to student English learning. Thank you.
Okay, thank you the team from the National University of Tainan, Taiwan. Thank you. So I mean, because the time constraint, we did not play the demonstration on the video, but we already put the demonstration on the competition website. So I mean, please, thank you. Would you please give some comments or question, then use case for this team?
Okay, I just had a quick question. Sorry, your hardware. You said that one hardware is the learning tool and the other one is AI FML robot. So do you use both of them or just one of them? And also, my question is that is the hardware that you have designed for this is only working with FML or FML is just one use case or one software that we can install on it?
Okay, Zhonghan or Lin Bin or Alice. Alice, maybe you can answer.
We use AI FML robot, KBL, or the other robots and learning tools together, because the students can speak English to a robot and the learning tools can receive the information and also can say something. And there for the learning tools and the robots, we just one of the applications, and the learning tools and the robots also has the other functions inside their hardware. Thank you.
Okay, thank you, Amir. And then use case, please. Thank you.
Thank you very much for your great presentation. Could you explain how to measure learning performance?
Okay, how to measure the learning performance? Maybe Lin Bin or Zhonghan. Can you explain how to measure the learning performance, or Alice? Zhonghan is okay for you.
Do you use some score of the English test?
We use some scores. When students speak to robots, we will collect their data, such as how many times they practice, how long the practice, and the other factors. We consider 3 factors, but it's just an initial step to do these researches. We just want to the students, they will not be afraid to speak English. So if there is the robot or learning tools such as AI tools introduced to the classroom, the students will dare to speak English. And with this such data collections, we have this data and we can use to do the research function to promote a tool to the teachers or students as a tool to help them evaluate how much they improve about their English speaking. Thank you.
Okay.
Okay, thank you.
Okay. It's okay. Thank you. So because of the time constraint, so now we will show the next video. So please, thank you. Claire. This video is for the G system for the learning tool. Please, thank you.
Z-System Technology Corp, including smart video record and playback, video conferencing and real-time translation, students self-study and review, enterprise talent training and testing, and problem-based learning system PBL. We always hope to do more for you.
Hello, everyone. It's my great pleasure to invite the CEO of G-System Technology in Taiwan to introduce the IEEE 1855 product on AIoT FML learning tool. Shen Qian, please. Thank you.
Hello, everyone. I am the CEO of Xintong Technology Corporation Limited. My name is Shen Qian. First of all, I'm very grateful to meet Professor Li Jianxin of Tainan University. This is an excellent team, so that we have the opportunity to work with AI FML project together. And I am thanks the team that our company get a higher industry value. At the same time, I am also very grateful to other company partners who can participate together. You are all great. And then our company mainly focuses on the field of artificial intelligence and the relevance of image and audio streaming, voice to text, image processing, traffic recognition, and so on. We are work together with the Mingwei company to create the AI OT FML learning tool version 2 hardware, and work together with the team of Professor Li Jianxin and follow the IEEE 1855 standard for body makeup language. And is communicated with using hypertext protocol. And our teams work on create the application and the teaching material to help teachers and the students to understand how to use FML to create applications. Also, we are committed to speech to text technology with the team of Professor Li Jianxin that combine into the AI FML applications and maintain the AI FML cloud services. Okay, and the following pages shows the result of application using AI FML with the AIoT FML learning tool V2 hardware. There are 3 input and 1 output variables. And this page shows the reasoning architecture to it's learning from body variables to have 27 body rules. And finally, we got a better tuning result of modifying the input and output body variables. And thanks for your listening.
Okay, thank you for the G-System company for contributing on the AI FML 1855 product, and thanks for the Ministry of Taiwan of Science and Technology in Taiwan for supporting this project. Thank you. Okay, this video is just to show how we cooperated with G-System about the learning tool for the student learning in Taiwan, and in the future we hope to promote to another countries. So because of the time constraint, so Gina, So because next the elementary school team from Tainan City will have 3 teams. Is it okay for you if we show all the video, then you ask the question to save the time?
Okay.
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 Thank you, Marigina. So Claire, please. So I think the session 2, we will show all the video, then the student answer the question from Marigina. So Marigina, thank you very much. So Claire, please.
Hello everyone, my name is Jun Kai Zhuang. I come from London Elementary School, Taiwan. My report title is AI FML for music listening. My leader comes from NUTN and London Elementary School, Taiwan. My team name is London King of Gods. This is my outline. This slide shows our motivation to AI FML for music listening. This is our methods. This slide shows the AI FML with AIoT application. Step 1, human and robot co-learning. Step 2, record and collect data. Step 3, build KB and RB. Step 4, use PSO to do machine learning. Step 5, after learning KB and RB. Step 6, machine learning until a best model. This slide shows fuzzy variables, 5 input variables: attention, rational, emotional, fatigue, and stress. Output variable, feeling. This picture shows before learning knowledge base. This picture shows the machine learning structure. There are 32 rules. These 4 pictures show our photo to collect our data when listening to sounds. Our data come from 8 sounds, 2 Korean, 3 English, 2 Japanese, and a Taiwanese sound. Training data come from open data and learn the AI FML collect. Testing data come from learn the AI FML crowd. This picture shows after learning knowledge base and for 50 generations. This picture shows after learning knowledge base for 100 generations. This picture shows after learning knowledge base for 500 generations. This picture shows training data results. After learning, MSE becomes lower and accuracy becomes higher. This picture shows test data results. Finally, this is our conclusions and experience sharing. Different people like different sounds. MSE becomes lower and accuracy becomes higher after learning. I am very happy to have this chance to wear a very expensive PCI device. Thank you very much for your listening.
Okay, thank you. So Claire, next video, please. Thank you. Because the time constraint, so for the session 2 and session 3, we will show all the video, then ask the question. So for the Tainan City, Marigina and Soto will be the referee, and for the Kaohsiung City, the Marek Reformer and Giovanni Acampra will be the referee. So Claire, please next video. Thank you.
Hello everyone, my name is Hong Yi-mei. My report topic is AI FML robot application to intelligent speaking English. My leader come from NUTN and Render Elementary School, Taiwan. My team name is Render We Are Great. Here is the motivation. This picture shows our AI FML intelligent speaking application. There are 6 tips. This is our input fuzzy variable, practice time, practice number, and average score. This slide shows the value of the before learning knowledge base. This picture shows the before learning knowledge base. These 2 tables show AI FML rule base. This picture shows the machine learning structure. These 3 photos show we were collecting data as AI FML club. Next, this is our training data. They come from Render AI FML Club and AI FML International Academy. Total number is 172. Here is our testing data. Total number is 17. This slide shows after learning KB for 15 graduations. This slide shows after learning KB for 100 graduations. This table shows results of training data after learning MSE is lower. This table shows results of testing data. 15 graduation is better. Finally, this is our conclusion and experience. Collect student learning data. Honestly, student learning performance. Control KBRB using AI FML. Human and machine co-learning. We are very lucky to have this kind of training. It is a good way to learn AI using AI FML. Thank you very much for your listening.
Okay, thank you. So Claire, because of the time constraint, would you please to play the next video? Thank you.
Hello, everyone. It's my great pleasure to invite the President of Medium Wave Intelligent Communication in Taiwan, President Ye, to introduce the IEEE 1855 AIoT FML learning tool for real-world applications. President Ye, thank you. Please.
Thank you, Professor Lee. Hello, everyone. My name is Tender Ye, President of Media Wave Intelligent Communication. Media Wave is located in Hsinchu, Taiwan, a company with strong experience on embedded system design and have close connection with many famous IC vendors in Taiwan. Today, I want to introduce you about the learning tool for AIoT FML made by Media Wave. Next. The learning tool is a development board specially designed for STEAM application. It is suitable for students to learn about embedded system design and edge computing, including understanding the characteristics of these systems, doing development and debugging. The board is built up with a strong CPU and a large enough RAM size for many applications like STEAM, neural network, artificial intelligence, or signal processing. On the other hand, the board is using one of the most popular languages on the world, Python. Use Python to design so that students can make use of many free and useful resources available on internet, designed by Python, to fast and efficiently create their own art. Besides the board, we have a series of boards designed for different level students and applications, and all of them belong to Junior Pi family. The boards in this page is the most powerful one in Junior Pi family and called Junior Pi Thomas. It follows IEEE 1855 standard for fuzzy markup language and communicate with AI FML. Next. This is a fuzzy set distribution before AIoT FML training. We can see the learning performance is normally distributed. Okay, thank you. Next. This is a network modeling used for AIoT FML machine learning experiment. Next. This is a distribution after AI FML training. Okay, we can see the output is changed with the previous one. Next. That's all my presentation. Thank you for your listening today. Thank you.
Okay, thank you, President Ye, for the contribution to IEEE 1855 product in Taiwan. Thank you. Okay, thank you. So next, Claire, please show the next video. The next will be the demonstration from Render Elementary School. So please, thank you. So Claire is okay for the video. Hello everyone. Now we invite the elementary school student to demo FML for AIoT applications. So Junkai, please, thank you.
Hello everyone, my name is Junkai Zhuang, and I come from Lunda Elementary School, Taiwan.
Hello everyone, my name is Hong Yi Mei.
Hello everyone, my name is Zheng Hui Wu.
Hello everyone, my name is Hong Yi Su.
We are going to show the AIoT application, the PCI music listening. We use AI FML platform to show the result on AIoT FML learning tools and AI FML robots. Let's start. If attention is low, rational is low, emotional is high, fatigue is high, and stretch is high, then feeling is frustrated. Let's see the AI FML Mooncar result.
I feel frustrated.
Let's see the AIoT FML learning tool result.
I feel frustrated.
Hong Yi, next please.
If attention is low, rational is high, emotion is low, fatigue is high, stress is low, feeling is sad. Let's see the AI FML Mooncar result.
I feel sad.
Let's see the AIoT FML learning tool result.
I feel sad.
Zheng Hui, next please.
If attention is high, rational is low, emotion is high, fatigue is low, stress is low, so feeling is happy. Let's see the AI FML Mooncar result.
I feel happy.
Let's see the AIoT FML learning tools result.
I feel happy.
Okay, next please.
If attention is high, rational is high, emotional is low, fatigue is low, and stress is low, then feeling is pleasant. Let's see the AI FML Mooncar results.
I feel happy.
Let's see the AIoT FML learning tools results.
I feel happy.
Okay, thank you for the elementary school student to show the AI-FML platform connect to the AIoT device. I think it may be the first time for the elementary school student to connect the AI-FML and AIoT device, including the learning tools and the mooncast in the world. In the future, we hope to promote the gender elementary school students' experience to different countries. For example, Italy, Spain, Canada, and Japan. Thank you. Thank you all. Okay, thank you so much, Gina and Anna. Okay, please, thank you.
Thank you very much. And first, congratulations to all the three teams. And because we are under strong time constraints, if I understood correctly, I would have the same question actually for all three groups, and which would be, could you please underline the part of your project you are the most proud of? So maybe the most difficult thing you had to achieve, or anything, the thing you are the most proud of for your project.
Okay, thank you. So the first team, Junkai, would you please? Junkai and Hongyi.
Sorry, I explain in Chinese. 那个老师问你们说，你们在这个专案里面，你们做了什么事情？这样 OK 吗？
什么是最困难的？
对，什么是最困难的 ？OK。
Okay. Junkai, please.
Machine learning.
Machine learning.
Yes.
Okay. And Su Hongyi.
Say English.
English.
You mean speak English?
Speak English.
Is the most difficult.
Okay, speak English. Then Mei Hongyi, are you online? 还有谁？吴正辉 are you online? And Lin Li. No. Oh, sorry, because the student they are at their home. So because in Taiwan now is 7:20. Wu Zhenhui, please, thank you. In the dinner time, maybe the student go to the dinner. I'm not sure. Zhenhui, please.
什么是最困难的？
Zhenhui, you should open your voice.
I feel KB and RB is so difficult.
Oh, build the KB and RB is
so
very difficult. Okay.
Thank you very much, and congratulations to all of you, really.
Okay, thank you, May Gina and Anna, please, thank you.
Hi, congratulations to all your achievements. There were great presentations. You all were dealing with emotions. Do you think that emotions, looking at different cultures, not only Asian culture, but European, American, people from Australia, would make difference in your system, in your model?
Okay.
Sorry, I
explain in Chinese.
就这位老师问你们说，就是你们不是在做那个脑机界面，然后不是有不同的情绪吗？可是他认为说，哎，亚洲的情绪不一样，欧洲的情绪也不一样，那你们觉得呢？
俊凯。
然后你怎样解决？
俊凯 ，please.
I don't know.
Okay, and Su Hongyi, please.
Yes.
Maybe you can construct different KB and RB.
Do you think if you construct the different KB and RB is okay?
Or machine learning?
Or machine learning?
Yes. Yes.
Yes, okay. And Wu Zhenhui. And Lin Li. Lin Li, are you online?
Hello.
Hello. Lin Li, could you please open your camera and say something?
Oh.
Lin Li is okay for you. Okay, please, thank you. 你觉得亚洲、欧洲不同的那个地方的人情绪会不会不一样？
会。
Could you please explain in English?
Yeah.
Yes. Okay. Okay. I'm sorry because the student there in the elementary school student about 11 or 12 years old and very, very young. Okay. Thank you. Thank you, May Gina, and thank you, Anna. Thank you very much.
Thank you.
Next,
great job.
Thank you.
Thank you very much.
Thank you. And next, we will invite Marek to and Germany Accompany to be the referee for the Kaohsiung City students from Kaohsiung City. So Marek, hi, how are you? So because the time constraint, so we will show all the video. Then you ask the question final. It's okay for you? Okay, thank you. So Claire, would you please help to show the video? Thank you. Hello everyone, it's my great pleasure to introduce the Dongguan Elementary School team from Kaohsiung, Taiwan to introduce the AI-FML applications. Yiqiao, please.
AI-FML application for emotional performance based on human brainwave. Offline, first, introduction. Second, machine learning process. Third, original data and training data. Fourth, knowledge base and role base. Fifth, FML machine learning. Sixth, result, and the last is conclusion. Introduction. We detect children's brainwaves and convert to 5 physiological indicators to make training data. Next, use training data to list the machine learn. As last, we use our testing data to test our model and find the optimal model. Furthermore, we can also connect our FML prediction model to a KB robot, which can also make the originally difficult program interesting. And that is our machine learning process. First, we get the original brainwaves data, and we do the data process normalize, and we can get our training data and testing data. We put the training data for FML system to machine learning, and we can get a prediction model. We put the testing data for prediction models and choose the base model, and that is the optimal model. And we use the last optimal model to do our inference. And that is the FML platform. This is original knowledge base diagram. We create row base is like that. That is our row base diagram. We have 243 rows.
And this is our training data for English song. This is training data for Taiwanese song. And this is the training data of Japanese song. And this is our learned knowledge base diagram. You can see that it's different from the original knowledge base diagram. And this is our result for Japanese song. We use the testing data to test our model, and we will get the MSE and accuracy. So the 15 particle 300 generation is our optimal model. And for the English song, 15 particle 300 generation is also our optimal model. For the Taiwanese song, 15 particle 200 generation is the optimal model. And this is where we do the inference in the FML. At last, the conclusion. It helps us make the best model by adjust the number of the particle in the particle swarm optimization, which is PSO, design of fuzzy rows and intervals, and change the generation number of machine learning. Take the training data to optimize the knowledge base and rule base of FML. We found individual 9 models from English song, Japan song, and Taiwanese song. By testing, we found the individual optimal model. By the optimal model, we can inference the mood of the user. Thank you very much for your listening.
Okay, thank you. So
everyone, it's my great pleasure to.
Okay, so please, thank you.
Hello, everyone. It's my great pleasure to introduce the team from Dongguan Elementary School, Kaohsiung, Taiwan, to introduce the AI FML applications. So, Insen, please, thank you.
AI FML application for power estimation of solar energy in school. Outline 1. Introduction. 2. Machine learning process. 3. Big data, training data, and testing data. 4. Knowledge base and role base. 5. Predict model. 6. Inference power quantity. 7. Conclusion. This is our school solar energy generation. We want to know solar panel power generation, so we decide to use this product. Introduction. We collect 319 data of power quantity for the solar energy panel in our school. We normalize these data for 360 training data and 30 testing data. We use PSO algorithm and series different protocols and generation to optimize the AI FML. We open 9 predict model by FML machine learning. We test the 9 predict model. We select a model with the least MSE as our optimal model. Put the model in our FML platform to inference power quantity. Machine learning process. We collect 319 power generation data. We do the normalize and we have trained data and training data. We show in the FML machine learning and we have the predict model. We test the predict model, we have the open model, and we can get an inference.
Here is our original data. You can see temperature, sun watt-hour, sun time, and power quality in here. This is our normalized data, training data and testing data. We normalize the original data, then we get normalized training and testing data. Here is our original knowledge base. Our input is temperature, sun time, and sun watt-hour. Our output has power quantity. Here is our original knowledge base diagram. Here is our original row base diagram. We have 36 rows.
This is our knowledge base diagram. You can see the original knowledge base diagram has changed. This is our different model testing. We have 9 models. Then we do testing. After testing, we get MSE accuracy. Model 6 is our best. MSE is low and accuracy is high. So model 6 is our optimal model. This is our FML inference. This here is our target, and here is our FML inference. You can see the difference. Square error number is very small, so this means our model is good. Conclusion. Particles 1 optimization is used to optimize the knowledge base and role base of fuzzy inference system. The more generation, the higher the accuracy we get. When the generation number increases, MSE has a decreasing trend. Thank you for your listening.
Okay, thank you very much for the Dongguan Elementary School student from Kaohsiung, Taiwan.
The next, please. Thank you.
Hello, everyone. It's my great pleasure to invite the COO of Circus Pi in Taiwan to introduce the IEEE 1855 AIoT FML learning tool for real-world applications. So, Yin Zhang, so please, thank you.
Hi, everyone. I am Eric Xiao, the Chief Operating Officer in Circus Pi from Kaohsiung, Taiwan. We are a technology company with development technology teaching science from elementary school to university. Main products of our company include steel, flash, AI, and IoT teaching tech. We are glad to cooperate with National University of Taiwan, Dr. Lee, give the chance to provide AIoT FML, LT version 3 and Mooncar for this research project. Next, I will show you our technology teaching set. Next. In this slide, you can see AIoT tools. We also follow IEEE 8055 standard for FML. The communication method with AI FML using HTTP protocol. The AIoT tools kit based on microcontroller plus combined with IoT sensor like humidity, ultrasonic light sensor, and push button. Also, photo or flag, we can use it to teach students about the topic of AIoT. Next. In this slide, we also show you the moon car and satisfy. The IoT tools also follow IEEE 8055 standard for FML. The communication method with AI FML is using MQTT. This toolkit is used based on microbit, or you can also use DDR10 microcontroller to teach students how to control a moving vehicle. Next. This slide shows the experimental architecture of the learning knowledge base, include available left brain aviation label, right brain aviation label, fatigue, stress, and emotion. Next. This is the machine learning structure. Next. And this is the experimental result. You can see it's useful and helpful. So we hope in the future we can promote the learn kit to students from different countries in the world to make them learn AI with more fun. Thank you for your listening.
Okay, thank you, Circus Pi, for the contribution to IEEE 8055 product. Thank you.
The next, please.
FML for robotic game of Go and robot co-learning applications. This is an outline. Please have a look. Introduction. The goal of fuzzy machine learning is to make DDFS predicting win rate close to that of ELF OpenGo. We collect 6 data of AlphaGo and human games, and we do some data processing. We use this optimal model to inference another game and get the win rate, to compare with the win rate of OpenGo and draw their curves of win rates. This is machine learning process. First, we collect AlphaGo 60 games. Next, we normalize them and do data processing. After that, we conduct individual training of 60 games, and then combine the 7 smallest rounds of MSE data to form training data. Then we randomly choose 20 rounds of testing data. After FML machine learns the bureau data, we can get some predictive models. After, we use this optimized model to test the 20 games. This is our training data. This is our original data.
These are our original knowledge bases. Input have DBWR, DWWR, DBTNR, and DWTNR. Our input level have low, medium, and high. Our output have EDWR and EWWR. Our output level have low, medium, high, and high. These are FML platform. These are original knowledge-based math, goal of black and goal of white. These are original rule-based diagram. These are learn knowledge basics diagram, goal of black and goal of white. These are learning result of black, number of particles, 5, 10, 15, generation, 100, 200, and 300. These are learning result of white as the same idea.
This is the test result, and the table here says the MSE and accuracy of the goal of white. 01 is the test, which is by 10 particle and 100 training times, and 02 is by 15 particle and 100 training times. In 01 test, W15300 gets the highest rate because it has the lowest MSE and highest accuracy. That means this model is the best one. With the same idea, W15200 is the best model in 02 test. This is the test result of black. As the same row just now, B15300 is the best model in test 01, and B15200 is the best one in 02 test. This is our FML inference. Conclusion: we select 7 sets of data from the original data to make up the training data and the other 2 sets of data to make up the test data. The PSO algorithm is applied to optimize the knowledge and raw base of the fuzzy inference system. We implement more generation that can get the higher rate of accuracy and smaller MSE. Finally, we select the model B10200 and W15200 as the optimal model of go black and go white. Thank you for your attention.
Okay, that's the video. Claire, please, thank you.
Hi everyone, my name is Yixiang Xu, the president of Kinky Technology. Our company is located in Kaohsiung, Taiwan. The Web AI Developer Board we launched this year. It combines coding tool with Google Broccoli image training platform, and more importantly, it supports IEEE 1855 AIoT FML. In this video, we can see that Web AI can use face mask AI model, check if you wear mask or not. Web AI building Wi-Fi chip, you can use barcode scanner Google service to upload data. In this video, students use image training tool for image classification training. Cloud tool can carry out image training at the same time, training together. Then use programming tool to design program, make learning more fun. Web AI support IEEE 1855 AIoT FML. This is the fully set distribution before AI FML training. This is AI model training use the AIoT FML tool. Finally, after training, you can directly control the Web AI for display or edge computing. Thank you for your time.
Okay, thank you, Claire. So I think, Margaret, will you please give a short comments because the time is constrained.
Okay.
Maybe only one question for all the teams.
Yes, all of team.
Margaret, please, thank you.
Yes, congratulations at the beginning. Very first, fantastic job. One question: what do you like the most during the project?
Okay, Yiqiao. Yiqiao, please open your voice.
What do you like?
Like most is when I was doing the brainwave experiment, because I think that is I'm not tried that experiment before, so I think that is interesting, and that is a very good experience, because I can do that brainwave experiment, and that's for me and for my brain, and I think that is very good and I really like. So that is I like the most.
Thank you.
Okay, thank you, Yiqiao. Then Ziqian, please, another team. Ziqian, it's okay for you to answer the question. No. Jiacheng, is okay for you. Jiacheng.
你最喜欢的那个
Okay, please, thank you. Then
the same
Hui
question.
Yeah, the same question. Yes.
What do you like? What do you like the most?
你最喜
I
欢
like the inference because I combine many data and I inference, and I can find the most I can know model is good or not good.
Okay, thank you. Then Gui Hong is okay?
Yes,
Please, thank you.
I am honored to have the chance to join the activity. This is my first time to study what FML is. For me, FML is a new concept. I find this theory consequential to my daily life. I like to work with my friend.
Good. Thank you very
Okay,
much.
thank you. So I see the Emil. Emil, please. I see Emil. You raise your hand. Emil.
No, it wasn't raising hand. It was just clapping for them.
Oh, okay.
Yeah, thank you.
Okay.
It was great.
So Marek is okay because the time is
Yes, it's super.
Okay, thank you. So
They were
I
talking,
think
yes.
finally we would like to invite President Yang Hongdun to say final. Then we will and then the Anna. Then we will close this section because the time is over. So President Yang, please, thank you.
Okay, it's interesting for me. It's not a real academic research even for AI, but looks like a innovation educational program. Especially for high school, junior high school, senior high school, elementary school students, how to motivate them to learn AI, the most important technology in the future. You just look at, we have 4 companies work together in this FML system, establish hardware and the software, try to apply into the educational system in Taiwan, supported by city government of Thailand and Kaohsiung. They try to apply to several selected school for initiating learning system. I would say that's very interesting. We are not expecting to every student to learn this one, but motivate some of our talented students, more advanced students to learn how his father, maybe his older brother, learning in university. And anyway, I would say they use this kind of a learning system from daily life, more application every time you see. This maybe let them to learn AI more fun and more inspiring. So and then you guys must to have discuss how this kind of activity proceed even in Taiwan or learning together with our international partner. Let them share or learn together.
Okay, thank you for President Yang, because we have only 1 minute. So for take group photo together finally, then Claire will close our section. So please open your camera. Please, thank you. So Pei Yu, so please open all your camera. Then we will take Bao Zheng. So we will Zheng Hui, Hong Yi. Then please open your camera. Then we will take group photo. Then thank you. Wen Kai, please open. Okay, so Alice, please say 1, 2, 3, 8. Okay, finally. So Claire, please 1 second. Thank you. Because
1, 2, 3, smile. One more. 1, 2, 3, smile. And later. 1, 2, 3, smile. One more. Okay.
Okay, thank you. Thank you all. And thank you.
Bye bye.
Bye bye.
See you next time.
And Mother